Hey guys, today we're going to be taking apart this solar powered phone charger. What's interesting about it is that it says it's 100,000 milliamp hours. That I do not believe. No one should believe that it's 100,000 milliamp hours, and one, because this thing was around £15. Two is because 100,000 milliamp hour battery, if you go and try and buy one, a legitimate one, it would cost you around £1.5 grand, and that's nowhere near is the price that I got this for. So on the front we can see that it has a 2 amp out, it has a on and off button, it has the indicator lights, it also has a place where it can charge. It's 5 volts in and 1 amp out. Also, when you double press this button here, the light comes on, and you can double press it and turn it off. Single press makes the light flash brighter and shows its charging state. So currently it's charging this first bit, but to be honest, an improvement to this would be to completely short out all of the LEDs, because they draw more current than it receives at some points, depending on the time of day and things like that. Also, doing some calculations, I figured out that this thing should take 120 days for it to fully charge with solar panel working at maximum capacity, and that's highly unlikely. Okay, so let's get into it. There are some screws on the sides. There are 4 on each side, so 8 in total, and I'll just unscrew them. Okay, so I'm just gonna pop it open. We can just slide it off, I assume. There we go. That's come off. In here, there are 2 lithium polymer batteries, and here's the circuit board. So here's that's the button right there, and that's the LED. These LEDs are not are actually circuit mounted LEDs. So if I was to click there and then click it once, you can see that it's a surface mount LED that's getting brighter and dimmer, and then that's just going through these shells which look like LEDs to make it think that there is actually LEDs there. So now I've taken it out of the white shell. There are some pads to protect it from being crushed and the metal getting... It's just to absorb the shock of, say, if I was to drop it or something like that. So on the circuit board we have the female USB adapter right there. We have the LED, white LED. We have the female micro USB adapter. We have another female USB adapter. We have a push button. We have LEDs as charge indicators. We have an inductor here. It's just a coil of wire. We have an IC, or integrated circuit, which is the black thing right there. So the solar panel is glued directly to the lithium polymer batteries. I suppose the solar panel kind of acts like a shield for the batteries. I wouldn't want to pull or push or tug on these batteries much, because I might pierce them, and as you all know with the Samsung Note 7, that could be extremely dangerous. Okay guys, so I did some research and I found out that these batteries are actually around 2,600 milliamp hours each, so it comes to a total of around 5,200 milliamp hours. So nothing near the 100,000 milliamp hours they suggest, but it's not bad. Your phone's battery is probably around 2,500 milliamp hours, but if you've got a really up-to-date model, then you probably have 3,000 milliamp hours. Something I suggest with these is that you desolder the LEDs, and that's as easy as literally putting a soldering iron on top of them and breaking them. And there we go. All four of them are done. The LEDs are not gonna light up ever again, and just to prove that, press that, nothing happens. Other than this LED, but you can just have that off. Okay, I'm gonna put this back together and do some more tests, see if it charges. But thanks for watching, and I shall see you next time.